Hi everyone, welcome to my YouTube channel TechDataEngineer. So in the system design concept series, I'll start with the second part, storage layer design. Okay. So in our first video, we have seen in JSON layer design how and what are the approach we have to follow. We are taking the data ingestions. So now in this video, we will see storage layer design. Okay. So how to store the data so that it will be easy to access and cheap and optimized, also cost optimized. Okay, so we will see in this video. Okay, so let us start with the data lake, data warehouse versus lake house design. Okay, so we have to see like in which scenario we are going for data lake and data warehouse and lake house. Okay, so I'll explain with this the real time analogy. Okay, so why we are storing something? Because if we have to store them properly so that like people can find and use them fast and cheaply. Okay, so something if we are storing, so if we can find it out very fast and we can like in access it in very cheap way, then that way we can say like we are storing in optimized way. Okay, so fast and cheap access. So let us understand with the analogy of huge library. Like we are suppose what is the data lake basically? So data lake is something, but we are big raw storage warehouse. Okay, so something like if like books are coming, we are storing on that place. Okay, so if you talk about the data, we are storing in data lake like a store. We are storing structure, semi-structure, unstructured data. So any data is coming in any format, we are storing like video, audio, file format, anything. So example of a storage layer is like we have S3 in AWS, GCS we have in Google Cloud, and ADLS we have in our Azure. Okay, so these are the storage system. So what is the benefit of that? Low cost, because we don't have to arrange that. Okay, like on what format data is coming, we are just storing that. And schema on read, like that's the flexibility, because whatever the data is coming, only schema is only at the read time. Okay, and that is stored everywhere. Okay, so that store wherever the our data center are there, that get stored to every location, so that would be easy to access also. So if you talk about the real time analogy, we can say like it's like a godown where you can store everything as it is, like book, magazine, photo, old newspaper, without arranging much. Okay, so we are not arranging like a books in a books shelf, magazine in a magazine shelf, photo in a photo shelf. No, we are just whatever the things coming, we are just bringing it and storing it the place. Okay, so that is cheap, and we can store in any format. That is the raw data. It's messy, but yeah, it's raw data, good for data scientists and ML, because the data is stored in single places. Okay, so example I have already seen like GCS, ADLS, S3. Okay, so what is the cons of that? Because if it is ungoverned, so obviously data will be swamped. Okay, so query performance need work, rework we have to do. That is the data lake. That is the basic one. Okay. So after that, we have some optimized data we get, that is called data warehouse. Okay, so what is the data warehouse? So data warehouse is something like a proper library where books are clean, arranged in shelves. Okay, that is properly indexed so that it will be structured. It is fast for analysis, fast for access. It is bit expensive because we are investing time and resources for arrangement. Okay, but data warehouse is something where we are storing the structured raw data. Okay, structured data. So that is data warehouse. Why we are using data warehouse? If we wanted the data that is to be analytically ready, so that we can take the data and we can do some analysis on that. And so that is used for reportings or any ad hoc SQL. We are using the then we are storing in the data warehouse. So data lake is something where we are storing the raw data. We don't want that to analytical ready. If we want analytical ready data and some arranged format, a structured format, then we are using the data warehouse. So BigQuery, Snowflake, Redshift, these are the example of that. What is pro of that? So that is the fast SQL we can perform on that, built on in optimization, We have acid like semantics, security features they have. What is the cons? So cons is like we have to give the cost per query or storage. Okay, so that is the cons of the data warehouse. Now third is the lake house. So what is the lake house? Lake house basically is a it's a combination, it's a hybrid approach, okay? So lake for storage and warehouse feature like a seed metadata or indexing that we are using. So if you are using both the approach, lake house and sorry, data warehouse and lake, that is called lake house, okay? So if you see the normal analogy, so it's like a modern library where row box come in, get cleaned automatically and instantly become arranged. Okay, so if your data is coming as a raw and then with the help it is getting cleaned and arranged, that is called lake house. It's like a hybrid approach. So it is implements table format for object storage like Delta, Iceberg, OD. So what is the pros of that? That is a single platform. Okay, curated. We can support streaming, batch, time travel. These are the features that is supported by Lakehouse. Okay, but that is not supported if you want batch or time travel or streaming or a schema evaluation that is not available with the other like lake or data warehouse, okay, but that is available with the lake house. So these are the features. So based on requirement you have to choose lake house or you have to choose the data warehouse or you have to choose the lake. Okay, only you want the data um, that only for a storage purpose, not the analytical, then you have to go with the lake. If you wanted data to be used for analytical, then you can go with the warehouse. Okay, if you want some schema evaluation time table, you can go with the lake houses. So based on this requirement, you can design your system. Okay. Now next part is the file format. So we can like we have like Parquet, ORC, Avro, or Delta. So, okay. So this Parquet is basically a we have columnar format. So by columnar format is like it's a book arranged by topic inside boxes. Okay, so that is based for analytical workload. A storage column storage. So column storage is efficient. So why column storage is efficient? I have already explained in the my previous videos, other videos. So you can see that Parquet file format or ORC file format. Why that is efficient? So I have already explained that. So as we know, that is efficient for a storage. That's why we are using the columnar storage. Okay. Then why? Because we have the compressions and encoding per column is required. So okay, this is small size and this have the fast input output. So good for predicate push down or vectorized reader. So that's why we are using the Parquet file. So when we are using the ORC, that is ORC is also columnar. We have the column by column storage, and that is similar to Parquet, strong in Hadoop ecosystem and Hive that also support Stripe level indexing. Okay, so ORC is something like we have book stored plus compressed neatly. Okay, so if you wanted to understand from the book analogy, so we can see like ORC is something like we have book stored plus compressed also. Okay, so compressed neatly so that you will go and you will get it. Okay, so what is Avro? Avro is basically a row based. Okay, so based for event or streaming, serialization and message format like Kafka and streaming. Okay, fast for write heavy, small record workload. Okay, and support schema or history evaluations. Okay, so like that is one book per page, row wise. Okay, that is called row wise storage we are using. Then the next is when we are using the delta. So delta basically the table on top of the Parquet we use the acid property. So it is using acid properties. They have the transactions feature, time table, schema evaluation and enforcement. So we are using the table. So if you want these features, we are using the table delta table format. Okay, delta file format. So columnar is basically used for that is read only required column, not the entire file. That is highly compressed. So if it is highly compressed, it will save the cost. It is optimized for analytics like BigQuery or Spark Data. That is support schema evaluation. That is flexible. Okay. So so suppose if you understand with a simple analogy, suppose you want in a book only the chapter 3. So Parquet lets you pick just that chapter instead of reading the whole book. Okay, so you can directly get it that chapter. Okay. So that is the benefit of storing the column wise. Okay. So if you want storage as a like analytical person OLAP, we can use using we can go by columnar format. Okay. Okay. And OLTP you can store the row wise. So always remember if you have something related to OLAP, we can go with column. If we something related to OLTP, we can go by transit. We can go by row storage, like that is fast writes, fast single record, like Postgres SQL, MySQL is the example of that. And if read only needed column, then we can and faster for aggregations, then we can go with OLAP and column for storage. Okay. So these are the example of that. And so in which scenario you have to use, you can go by that. Or either your business use case required OLAP or OLTP, so you can choose the data format, file format based on that. Okay. So I have already explained here analytical table section. You can go with Parquet, streaming, Avro, need a seat per timetable, we can go with the delta iceberg and hoodie. Okay, so this in this scenario we can use this file format. So in system design, these are the things only we have to take care, right? If you're designing the system, so based on your requirement, based on the requirement, you have to choose that component. Okay. So I have already explained why we are performing, why we are why we are preferring the Parquet file because of column layout. It has easy predicate push down, statistical metadata, wide ecosystem support, good for vectorized execution. Okay, pre-column encoding compression is there for storage. So we are using this basically Parquet file format. Okay. So if we are understand with the analogy I have already written here, so Parquet is like storing each column its own drawer. Okay, to answer a query, you open the drawer unit. Whenever so whatever you need, you can directly open. Okay, you don't have to go by each and every drawer because you know. So that's why we are storing the column by column because if on which particular column you wanted to perform something, you can go, you can pick that column. You don't have to go row by row. In the case of row by row, you have to select suppose one column I wanted to do some analogy on that column, then you have to go row by row. From each row you have to select that particular column value. Okay, so that would be very I can say that is not the efficient one. So that's why we are going with column storage. Now the next thing is partitions versus clustering. What is partitions and what is the clustering? So partition is something like putting books in a separate room by year. Suppose I wanted 2000, so I have a library system and I wanted 2023 book is in a single drawer, 2024 in a single. So that is called partition. So year wise I am doing the partition. So that's why in real time also you can split the data set by column, either by date, by country, by column ID, anything. Okay. So if you put the date today, date tomorrow, date, so you can go, you can pick it by date wise. Okay. So that is called partitioning. So we can partitions the data. Okay. What is the benefit of partitioning? Like enable the partition pairing. So query that field. So suppose I wanted the only 2023 record. So I'll pick only the 23 record. Okay. So that is the benefit of partitioning. We have to query on that particular things. Okay. So that is the benefit of partitioning. So we can do the partitions date wise, country, customer ID, anything. Okay. And what is clustering? So clustering is basically within the partitions, cluster sort data one or more column. Okay. So now if I have seen that, suppose in a library system, I can understand. So suppose I wanted only, so I have already partitioned the data year wise, like 2003 data, 2024 book, 2025 book. But in that also that partitions, I in 2020, I want this book with a certain author, so we can cluster by that particular author user ID. Okay, so within partitions cluster sort data by one or more column to improve the locality and that reduce the input output range query. So clustering will help within the partitions to fetch the data more efficiently. Okay, so tools like clustering in BigQuery, we have JOrder in the Delta table, sort cluster in Snowflake, clustering in BigQuery that will help to cluster the data within a partitions. Okay, so first it is coming as a data arranging as a partitions, then we are using the clustering. So if it is required, we can use that. Okay, so that is the difference between partitions and cluster. Okay. Now, again, we'll understand. I have already explained that column storage, row storage, and that I have already explained in the other video also. But now, again, we will see that the row oriented is the example of Avro, CSP, relational OLTP. What is the transactional operations we are doing? And these are the examples of row oriented. What the column oriented, the Parquet, ORC. So when we are using the row oriented, so row oriented basically when we are using if we have the transactional workload like OLTP where entire row is read or written, insert, update, delete. Okay, so efficient for small reads or write per row or low latency transactions. So low latency transaction required we are going with the row oriented. So when we are choosing the column oriented, that is very important whenever we are designing. So columnar is always good for analytical, that is OLAP, okay, where query read a few column over many rows, okay. So efficient for compressions, vectorized processing, scanning large volume. So if that is the scenario, we are using the columnar storage. So OLTP will always row, OLAP or analytical or aggregation always go with the column storage, okay. So I have already explained OLTP, OLAP, workload, many small read or write, low latency, schema normalized. OLAP where our large scanning, aggregation or join is there. Okay, so modern we are using the OLAP, online analytical processing and online transaction processing. So based on our requirement, we will choose. Okay, either either row wise or column wise OLAP or OLTP. Okay, now let us understand the hot versus cold storage. What is called hot storage? What is called so if we wanted the data frequently access, that we are using as a hot storage, okay. So low latency. So why we are choosing the hot storage? Because they have the low latency. So if we are frequently using the data, we want each and every time, every minute or every hour, frequently accessing. So if they have the higher latency, we will not prefer. So in case of hot storage, we have the low latency. But yeah, it has the higher cost used for frequently access or real-time data. So if you want that scenario, we'll go with the hot storage. Examples like SSD, backend object tiers, or active warehouse table, or cached partition. These are the example of hot storage. What is the cold storage? So they have the higher latency, like it will take time, lower cost for. So if you want like a for backup or historical or archival data, we'll go with the cold storage. Like example, we have the glaciers in AWC, cold LAN in GCP, archive tier we have. So these are the example of hot storage, cold storage. So if you want something like to perform analytical things, we wanted the low latency. If you want something for storage purpose, we can go with the cold storage, okay, which have the higher latency. Then we have the life cycle policy. So move data from hot to warm, then cold based on the age or access frequency. So if you wanted some data, now we are using frequently, we can store in the whole hot storage. But after some time, we are not using that data. We are using only for backup purpose. Then we can put it in the cold storage. So based on our need, we can define that policy, life cycle policy. Okay. Then next we have the object storage. So many of us we know that what is the object storage and why we are using that. So in we have S3, we have AWS, GCS, in Google we have an ADLS we have in Azure. Okay. So so what is the characteristics of that? Scalability. So massive object and throughput. So we can store massive data also and eventually consist of a strongly consistent. So they have they based on the consistency also we can store that data, okay, and that is the uh, like low cost per GB, high availability. So these are the feature of that, okay. So object storage have low cost per GB and that is highly available based because of the data center available nearby with our region, okay. So these are the feature of object storage, okay. So, what is the feature of like object storage we can see? So that is it is something like a object storage like it's a gained cloud warehouse. Okay, that is the unlimited scale, cheap, store any file like CSV, JSON, Parquet, HTML that is the durable and used in Delta Lake. These are the feature of that. So I have already explained it here. You can go through that. So why we are using the object storage, okay? Then we have the data versioning like Iceberg, Delta, or OD. So why versioning or table format required? Because the object stores files but not a strong from the not a strong table metadata and transactions. Okay, so in object storage, store the data but not their metadata and transactions. So that's why Iceberg or Delta and Hoodie comes into picture. So because of that we are required the versioning or table format. So we have the ACID transactions like automatic commit, consistency control and all. They have the snapshot features. Snapshot like till 10 p.m. if I'm storing the data, I can take the snapshot if after that we have the incremental data from 10 to 10:30, we can store that also. So these are the features we have. Snapshot we can take. We can go the time table previously and we can paste the data. We can do the schema evaluation. We can go with the partitions evaluation or compactions. But these features are not available in normal our object storage, and these are available with the our Iceberg, Delta or Hoodie. Okay. So we have the common file format like Delta Lake, that is for transactional log, Delta log with the JSON or Paraquet file. That strong support in Databricks, Delta Lake basically. Okay, so what is the feature they have? Like ACID, commit, time travel, schema evaluations. So we can use the Delta table. If Apache Iceberg, what is the feature of that? That designed for multi-agent use like a Spark, Flink, Trino. Okay, so that is immutable, manifest, and metadata free that is built for object storage. Okay. Then Apache Hoodie basically focus on incremental processing and upsorts. Okay. So we have the copy on write and merge on write. So these are the features they have. That's why you're using Apache Iceberg, Apache Hoodie, and the Delta table. So these are the I have summarized the differences. Like Delta, we have first class integration Databricks, easy time table, and simple workflow. Iceberg, we have better for larger scale metadata handling and multi-engine. And why we are using Hooty? Because of the strong ingestion upsort. If we have the strong ingestion and upsort support, we can an incremental pool required. We will go with the Hooty. So these are the differences and these are the features they have. So based on that feature, if something is required in our case, we can design the system. So we have seen two in system design concept. We have seen the two things. One is the ingestion layer and other is the storage layer. Now we will see the processing layer. What are the features? What are the tools? What are the things we have? We can and do that. If we'll understand each and every system design layer, then with a simple use case, we will see how we are using each layer and how we are completing the data pipeline or data system. Okay. Thank you. Thanks for watching.